In this video, we are going to continue to look at chemical reactions, but we will focus particularly on decomposition reactions. So what exactly is a decomposition reaction? Well, decomposition, or if something decomposes, it's going to break down. We're going to break a compound down into simpler substances. And in decomposition reactions, you will have a single compound as a reactant, and utilizing energy, we are going to break it apart into two or more simpler substances, which means it could be compounds and or elements that it's breaking into. So that requires something to cause the breaking of the bonds. So it could be heat, and then they would be endothermic, but we can generalize it. It can be any kind of energy, and we refer to those as endergonic. So I could use heat, I could use light, I could use electricity to facilitate the breaking of the bonds. There are three kinds of decomposition reactions I'm going to talk about. The first will be binary compounds that are made up of only two elements, and when they decompose, when they break apart, you will get merely the two elements that it is composed of. We will also look at ternary compounds where you've got three or more elements, and it will be more complex, the products that you will get. The particular ternary compounds I will talk about are, first of all, metal carbonates. So that would be a metal bonded to the carbonate ion, right? Carbonate would be the anion. And in that case, the pattern that has emerged that chemists have recognized, you will get a metal oxide, so that metal joined up with oxygen, and in addition, you will also get a second product, carbon dioxide. I will also discuss the ternary compounds, metal hydroxides, where you'll have a metal bonded to the hydroxide ion, and when that decomposes, you'll get that metal hooked up to oxygen, metal oxide, and you'll get water. So let's look at binary decomposition. And the first example I'm going to look at is mercuric oxide. So if I take some mercuric oxide and heat it up, well, this sounds like it's going to break apart, more than likely. It's going to be a decomposition reaction. Be wary, though. I'm going to kind of highlight here, heating up is not equivalent to burning. This is not a combustion reaction. Warming something up, you're not burning the material. All right, so mercuric oxide, I'd look up mercuric. I know that's going to be 2+. Oxygen's in group 6. I know that's 2-, so I know the formula is HGO. It's going to break into its two components, mercury and oxygen, and I have to remember oxygen is one of the diatomic molecules, so it's O2. This is not balanced. This is the correct skeleton equation, but it's not balanced, and once I balance it, I end up with this particular equation. All right, that was pretty easy. It was only made up of two elements. I'm going to get those two elements separate from each other once it decomposes. Let's look at another example, this time using light to decompose silver chloride. Again, I rely on things I already know. I look up silver, it's a transition metal, it's always 1+. Chlorine is a halogen, its oxidation state is 1-, so AgCl, and I'm going to get the two components. I'm going to get silver and chlorine, and again, I have to rely on things I'm supposed to remember, and that is chlorine is diatomic. There is the correct skeleton equation. It's not balanced. I go in and balance it, and it looks like this. So binary decomposition, that's pretty straightforward, pretty easy. Again, as long as you remember how to write correct formulas for ionic compounds, and that you remember which elements are diatomic, you should have no trouble writing balanced equations for the decomposition of binary compounds. Let's look at a second category, though. Now, ternary compounds. Let's look at metal carbonate decomposition. So metal bonded to the carbonate ion. In my first example, I've got calcium carbonate, which is a powder. Put some of it in a test tube, warm it up over a Bunsen burner, and it will decompose. Calcium's in group 2. It's 2+ is its oxidation state. Carbonate is a polyatomic. It's 2-. So I know the formula is CaCO3. You're going to have to learn what the pattern is. I should get a metal oxide. So the metal was calcium. So calcium oxide, 2+ and 2-. There's my correct formula. And then, of course, carbon dioxide is CO2. and I simply got the components that made up the original compound, and so the skeleton and the balance equation are one in the same. A second example, lithium carbonate chunks heated up. Lithium is in group 1. It's an alkali metal having an oxidation state of 1 plus. Carbonate is 2 minus, so Li2CO3. And again, the pattern is you get a metal oxide. So lithium 1 plus, oxygen 2 minus, so Li2O, and then of course CO2. And once again, the skeleton equation and the balance equation are one in the same. All right, so you need to know the pattern. You have to learn the pattern. The third and final decomposition category I want to look at are metal hydroxides. So a metal hooked up to the hydroxide ion. So let's say we take some calcium hydroxide pellets, warm them up. So it sounds like it's going to break apart. So it sounds like decomposition. Calcium is 2 plus, hydroxide, a polyatomic, is 1 minus. So CaOH2 is my only reactant. I should get a metal oxide, so calcium with oxygen. Calcium is 2 plus, oxygen is 2 minus, so there's the correct formula, CaO, and then my other product is going to be water. Again, the skeleton and the balance equation are one in the same. And a final example, if I take some sodium hydroxide pellets and warm them up, they will decompose. Sodium is 1 plus, hydroxide is 1 minus, so I know the formula is NaOH. I will get a metal oxide, so sodium is 1 plus, oxygen is 2 minus, so Na2O, and I get water. This time, it's not balanced, and once I balance the equation, I get this. So, decomposition reactions. We're going to break things down by adding energy to break the bonds. We looked at 3 types. I looked at binary compounds breaking apart into its components. I looked at metal carbonates, and I looked at metal hydroxides. So you need to know what the patterns are. Those are decomposition reactions.